All right, so there's four types. Number one is the parabola. We talked a little bit about it, but we're also going to talk about the sideways variety parabola. Then we have the circle. You're familiar more with that one probably. The ellipse, it's the egg shape. Actually, the circle is a specialized ellipse. Also, one other thing, this one's longer than it is tall. You can also get taller ones, ones that are taller than they are wide. So we'll say more about that in a second. And then fourth is a hyperbola. And so that's the four, where you got the right and left branches, and you got the upper and lower branches as well, hyperbola. So those are the four types of conic sections that we will talk a lot about here as we go. Okay? All right. So let's talk a lot more about here the parabola. We are familiar with these, y equals ax squared, a being any number you want there. When you have that type, well, you've got a parabola that either opens up or down. That's what you've got there. Now, I drew it opening up, but how do I know if it opens up? Well, it's all about the a, right? It opens up. It opens up if what? If a is positive. If a is greater than 0, it opens down if a is less than 0. But there's a couple other points to make here. Of course, we've got the axis of symmetry right down the middle on the opening up and down. It's a vertical axis of symmetry. We talked about that a little bit as we were going through. Don't forget about it. Now, this one's not shifted at all, so my vertex is at 0, 0, because there's no shift on it. But the other point I wanted to tell you about is called the focus. And on this one, we'll put it right there. What the focus is about, it's a nice little point because what happens is, think of this as kind of a mirror or a something that reflects, reflective surface, if I was able to do that. If you have rays, light rays, sound waves, if they come in and bounce off, come in parallel to the axis of symmetry, if they come in and bounce off the parabola, they're going to come in and all going to bounce to that particular point called the focus. It's the name because they all focus whatever side it is, they just bounce off and they reflect into that point. So it's called the focus. That's where if you have a telescope in this shape or a flashlight in this shape, that's where you want to put the lens or because that's where the light rays are going, or the light rays would reflect out if you've got a flashlight or something like that. But that's a nice little point to know in a parabola. And you have it, it's called the focus. Well, as far as formula goes, here's the way I determine the focus. P is going to be the distance from the vertex to the focus. And it's going to be always along the axis of symmetry. And here's how you get the P distance. So this distance right in here, that's going to be the P distance. From that from the vertex to that focus, we're going to call that P. Well, P, turns out, is 1 over 4A. 1 over 4 times A. Again, the A is just the number multiplied by the x squared. Turns out the p distance is 1 over 4 times a. Okay? For example, let's find a couple of draw a couple of parabolas here. All right, everybody got that one? All right, let's say we've got y equals 1/4 x squared. Y equals 1/4 x squared. Well, we know already a lot about that graph. We can graph it, no problem. Your vertex is at 0, 0, not shifted anywhere. If you want some other points, like I said, this is the one conic section where we'll use a little bit of a table. You can use them on others, but yeah, here we've got x. You can use 1, -1. Or -2, -1, to 2, that sort of thing. Those are always good points there. Without any shift anyway, so that would give me what? Y equals 1/4 and -2 squared. So that's going to be 1/4 times 4, that's 1. Y equals 1/4 when x is -1. Be 1/4, wouldn't it? 0, 0. You can check me on those, but I think the others follow suit. Here's what we get. At 1, I'm at 1/4. I'm at -1, I should say. And -2, I'm at +1. And at +1, I'm at 1/4. And at +2, I'm at 1. So yeah, I get this flatter looking parabola. Vertex is 0, 0. But now added to that, I will also want to find this focus point. And the way I find the focus point is I start off with the p value. It's 1 over 4a. What's my a in this case? It's 1/4, isn't it? My a is 1/4. And so the p is going to be 1 over 4 times 1/4. And that works out nicely because 4 times 1, you multiply those first. 4 times 1/4 is 1. So the p distance is 1. And so that means from the vertex, I come up from the vertex 1 unit, and so that gets me my focus point. And what are the coordinates then? Because it's a point. What are the coordinates of that focus point? Well, it'll be 0, 1. Okay? And so we'll do that also in conjunction with graphing these. We'll also find this focus point. All right. Now, if I have y equals -2x squared, well, that's going to put first of all, what kind of shape is that? Well, that's also a parabola, but it opens down. Okay. So this one opens down. And of course, we can see that come out to play, plays out on our table here. If I do x is -2, that'll be 2 times -2 squared. So that's a -2 times 4 is -8. -1, when x is -1, it's 2 times 1. So it'll be -2, 0. And then get the same basic values there. On the positive side, so we get 0, 0, 1, so -1, -2. -2, -8. And then on the positive side, you get about the same thing. Yeah, so we do get this parabola opening downward, okay? Where is, well, the vertex is still 0, 0. Will be unless it's shifted. What about the focus here? On this one? Well, the focus on this one, you'll get P is 1 over 4a. The a here being -2. You get 1 over 4 times -2, so you get P is -1/8, don't you? Meaning it being negative means, yeah, it's downward. And so your focus is right here, and so that puts it at 0, -1/8. That's where the focus point would be for that one. Okay? So far, so good. So we've done those parabolas before. We just added the focus in there. We now can talk about it. All right. Well, let's talk about the other side to parabolas, and that is x equals ay squared. We saw this on the handout. If we've got the y squared instead of the x, that's a sideways parabola. So it's either, and there's two options on the sideways. It can either open to the right or it could open to the left. Any guesses on how we can tell which way? Yeah, it's again on the A. If A is a positive number, greater than 0, then it opens to the right. If A is negative, less than 0, then it opens to the left. This type or this type. Same idea. Instead of up and down, though, it's right and left. Okay? All right, so let's now the good news on this is P is still 1 over 4a. The distance to the focus is still 1 over 4a. However, when let's put in some axes here. Where do you think the focus is on that one, location-wise? Well, the focus is going to be along the axis of symmetry, so it's going to be located inside here. The focus on your parabola is always inside, if you will, the parabola. So your focus is there, and then the focus on this one will be right somewhere along in there. But it is still, the P distance to the focus is still 1 over 4a. Okay? All right, now let's talk about some specific ones. Let's say we've got 2x equals y squared. First point to make on this one is I'm going to adjust this formula, and they put it in this format for various reasons, but I'm going to adjust this formula to make it more like we have been seeing, where I have just a variable x or y, in this case x, by itself. And so I'm going to take this equation, I'm going to divide by 2 to get the x by itself. And matter of fact, you can leave it in that form, but isn't that the same as x equals 1/2 y squared? Because I need that a kind of separated out, but isn't that top number coefficient you could say is 1? So that's the same as 1/2 y squared. So if I write it in that form, that's more like we have been seeing, and we can see a right there pretty clearly. In this form, I don't see a because this is not a, because the a is what's times the y squared. So that's why I move it over to that. That's the way I like to see it anyway. Okay? And so we see there, yeah, this is a sideways parabola. You got the x instead of the y squared instead of the x squared. So it is a sideways parabola, and it is a positive a, so it is going to open to the right. Okay. As far as graphing goes, do it the same way. Do a little table here. However, because the y is squared and not the x, let's pick out y values instead of x values. Let's choose the y values instead of the x's. So let's do y is -2, -1, 0, 1, and 2. Because the y is squared, not the x. It'll be a whole lot easier computing. All right, so if y is -2, then I have x equals 1/2 times -2 squared. So that's 1/2 times 4, that's 2. So x is 2 when y is -2. When x is When y is negative 1, we have 1/2 x equals negative 1/2 times negative 1 squared, so that's 1/2 times positive 1, so that's 1/2. 0, of course, is 0. X is 1. You get 1/2. X is 2. Y is 2. 1/2 of 4, so we get, again, 2 for the x. Okay? With me on that. So if I put those together, yeah, we'll see the sideways parabola come out here. 2, x is 2, y is negative 2. 1/2 x, negative 1y, 0, 0. 1/2 positive 1, and then positive 2, y is positive 2. Yeah, so there's our sideways parabola. All right? Where's the vertex? Still 0, 0. Yeah, these we're not going to shift too much, but no shift on it, so the vertex is 0, 0. What about the focus? Well, the p distance is 1 over 4a. And that's why I like to put it over there in that form, because there's a is 1/2. So you multiply 4 times 1/2, you got 2. 1 divided by 2, so the p distance is 1/2, but where is it? Well, now the axis of symmetry is here, and the p distance is always along the axis of symmetry. And so you go 1/2 inside from the vertex, so that's right there, isn't it? There's my focus. So where's the focus? Well, it's this point right here, which is 1/2, 0. Okay? Question or concern? All right. Let's do another here. And that one would be 3x plus 4y squared equals 0. 3x plus 4y squared equals 0. What do you think I'm probably going to do there for that one? Probably going to make it x equals. Move the other stuff over, so make it x equals. That would be what? 3x. Subtract the 4y squared, and then let's divide by 3. So I'm going to get x equals negative 4/3 y squared. Another sideways parabola. However, this one, which way? It's going to go left, isn't it? Because here a is negative 4/3. So that's telling me it's going to open the other way. Opens to the left. All right. Again, the table will bear that out. Do it correctly anyway, I guess. Again, since the y is squared, not the x, I'm going to choose out the y's here to be, let's just do negative 2 to positive 2 again. You can do others, but those will be some good ones. Gives a pretty good shape on it. All right, so if y is negative 2, x would be negative 4/3 times negative 2 squared. That would be negative 4/3 times 4, which is negative 16/3, or negative 5 1/3, or 5.333. Something to that effect. Is that right? Sound right? Y is negative 1. We've got x is negative 4/3 times negative 1 squared. So that's negative 4/3 times positive 1. That's negative 4/3. Negative 1 1/3. X is 0. Y is 0. X is 0. Same deal. X equals negative 4/3 times 1 squared. When y is 1, that's going to be negative 4/3. 1 1/3. And then y is 2. Well, that's going to be just like when x is y is negative 2, negative 16/3. Lots of symmetry there. Yeah, so that gets us a sideways one, doesn't it? Because here I go out negative 5 1/3, negative 2 would put me right about here. It's negative 5 there. All right, so negative 5 1/3 and negative 2 would be right about there. Negative 1 1/3, right about there, negative 1, 0, 0. And negative 1 1/3, positive 1. And then negative 5 1/3, positive 2. Be right above that one. Just sideways. Opening to the left. What about, so our vertex, still 0, 0. We haven't shifted it. The focus, well, P distance would be 1 over 4A. That would be 1 over 4 times, A is negative 4/3. So that's 1 over, look at this, negative 16/3, which you can plug that in your calculator if you like. Let me just show you here. That means 1 divided by negative 16/3, which, as you all know, means 1 times what? When I have divide fraction, you flip the fraction and multiply, right? That's negative 3/16. It'll give you some decimal equivalent if you put it in your calculator, though. So the P distance is negative 3/16, which means I would go back this way. Negative 3/16, there's my focus. So that's what? Negative 3/16, comma 0. With me on that. Sound okay?